Welcome to this deep dive
No.
into the phenomenon of gold rushes.
Okay.
We've got a really fascinating mix of sources to explore.
Yeah.
Historical accounts, geographical data,
Uh-huh.
and even a glimpse into the modern gold industry.
Awesome.
So get ready for tales of sudden fortunes,
All right.
mass migrations, and the lasting impacts of those who chased the golden dream.
What's fascinating about gold rushes is that they're more than just about finding gold.
Okay.
It's the frenzy that follows.
Oh, wow.
The massive influx of people from all walks of life, all hoping to strike it rich.
Okay, so let's unpack this.
Sure.
I mean,
Yeah.
finding gold is one thing.
Uh-huh.
But what transforms a simple discovery into a momentous historical event?
Right.
What are the essential ingredients, so to speak?
Well, a true gold rush involves a specific set of circumstances.
Okay.
It's like a chain reaction of human ambition, hope, desperation,
Wow.
and even greed.
Yeah.
And it's that chain reaction that truly defines a gold rush.
So it's a story about human behavior as much as it is about gold itself.
Exactly.
I see what you mean.
Yeah.
So it's not just about the quantity of gold,
Right.
but the speed and scale of the human response to that discovery.
Precisely.
Okay.
The gold acts as a catalyst,
Yeah.
triggering a wave of human emotion.
Okay.
It's the difference between a trickle of water and a raging torrent.
Got it.
The Wikipedia article describes it as an onrush of miners seeking their fortune,
Yeah.
which I think captures that intensity perfectly.
That's a great image. That really evokes the feeling of being swept up in something larger than yourself.
Yeah.
Is there anything else that defines a gold rush? Anything that sets it apart from,
Sure.
say, other types of migration or economic booms?
There's definitely the element of risk and uncertainty.
Right.
People heading to the gold fields were often leaving behind established lives, families, and careers with no guarantee of success.
They were embarking on a high-stakes endeavor.
Yeah.
Fraught with uncertainty. It must take an incredible courage to just leave everything behind for the unknown.
Absolutely.
Yeah.
And that element of risk added to the drama and intensity of these events.
Okay.
It explains why gold rushes attracted such a diverse range of people.
Oh, wow.
You had everyone from seasoned miners to farmers,
Yeah.
shopkeepers, even doctors and lawyers,
Really?
all drawn in by the prospect of quick riches.
The idea that anyone, regardless of their background, could potentially strike it rich,
Right?
that's a powerful motivator.
Yeah,
No wonder it captured the imagination of so many.
indeed.
Yeah?
And that brings us to another key ingredient,
Okay.
the perception of unlimited opportunity.
Got it.
Early on in a gold rush, before the easy-to-find gold is depleted,
Yeah.
there's a sense that anyone can make their fortune.
It's that gold fever mentality.
Right,
Like-
exactly.
Okay.
The belief that gold is just lying around for the taking.
Right.
Combine that belief with the risk and uncertainty,
Mm.
and you have an incredibly potent mix that drives people to extraordinary lengths in pursuit of their dreams.
So, to recap,
Okay.
we've got this element of sudden change,
Uh-huh.
a sense of risk,
Right.
the perception of unlimited opportunity,
Yeah.
and of course, the allure of gold itself.
Right.
Would you say that's a fair summary of what makes a gold rush?
I think that captures it perfectly.
Awesome.
And it's that unique combination of factors that makes gold rushes such compelling historical events.
Okay.
There are stories about human ambition, resilience,
Wow.
greed,
Yeah.
and ultimately the enduring power of hope.
It's remarkable how these events,
Yeah.
driven by the human quest for gold,
Right.
have shaped landscapes, created cities,
Yeah.
and even altered the course of history.
Now that we've established what constitutes a gold rush,
Okay.
let's look at how these events typically unfolded.
All right.
Our sources provide insights into the life cycle of a gold rush, which can be quite fascinating.
Sounds good to me. So we've talked about the initial stages with individual prospectors and their pans.
Right.
But how does a gold rush evolve over time?
The story is one of increasing complexity,
Yeah.
scale,
Yeah.
and unfortunately, often conflict.
Oh, wow.
As more people arrive,
Yeah.
the competition for gold intensifies,
Right?
leading to changes in both the methods of extraction and the social dynamics of the gold fields.
So if everyone's using pans,
Yeah.
eventually you're going to run out of easily accessible gold, right?
Exactly.
What happens then?
That first stage, the placer mining phase,
Okay.
is characterized by relatively simple techniques, low investment, and a sense of individual opportunity.
Got it.
But as the easy gold disappears, things start to change.
People need to develop new techniques.
Right.
Invest in more sophisticated equipment. What does that look like?
We see the introduction of sluices and rockers,
Okay.
which allow for faster processing of larger quantities of sediment. This leads to the formation of small partnerships, or teams, as individuals pool their resources and labor.
So it's still a relatively small-scale operation at this point.
Yes.
But we're starting to see the need for collaboration and organization.
Precisely.
Okay.
But as the rush progresses, the scale of operations continues to grow.
Got it.
Difficult to reach, placer deposits require tunnels and shafts,
Wow.
while water diversions,
Yeah.
dams and canals become necessary to access gold in riverbeds or to wash dry placers.
Wow. The landscape itself is being reshaped by the gold rush.
Yeah,
That's a pretty significant impact.
it is.
Yeah.
And this escalation in scale also leads to a shift in the social structure of the gold fields.
Okay.
Small claims owned and worked by individuals are often consolidated into larger tracts, controlled by companies or wealthy investors.
So the individual prospector, the
Well-
romantic image of the lone gold seeker,
Yeah.
starts to fade away as big business takes over.
In many cases, yes.
Oh, wow.
The gold rush becomes increasingly industrialized,
Yes.
requiring significant capital and sophisticated technology.
Right.
This often leads to the displacement of smaller, independent miners.
And I imagine this shift in power dynamics also leads to tensions and conflicts.
Absolutely.
Was it always peaceful?
Disputes over claims, water rights,
Oh, wow.
and access to resources became common,
Okay.
sometimes erupting into violence.
Yeah.
The gold rush, which began with a sense of opportunity and freedom,
Right.
could quickly descend into a ruthless competition for wealth and power.
That's a sobering reminder
Yeah.
that even amidst the excitement and hope of a gold rush, there were always darker forces at play.
Absolutely.
It wasn't always a story of individual triumph.
Yeah.
What happens when the placer deposits are depleted?
Yeah.
Does the gold rush just fizzle out?
Not necessarily.
Okay.
The focus often shifts to lode mining,
Got it.
which involves extracting gold from hard rock veins.
So instead of sifting through sand and gravel,
Exactly.
they're now digging deep into the earth. What are the challenges of this type of mining?
It requires even greater expertise,
Yeah.
capital investment, and technology.
Okay.
It's a far cry from the days of the lone prospector with his pan.
I can only imagine the challenges they faced, digging deep underground,
Yeah.
facing unknown dangers.
Right.
It must have been incredibly difficult and risky work.
It was.
Did they face any unexpected difficulties?
They did.
Oh, wow.
As they dug deeper, they were more likely to encounter gold locked in sulfide or telluride minerals,
Right.
which required smelting to separate the gold.
So now we're talking about an even more complex and expensive process.
Yeah,
And I imagine the cost of transportation also became a major factor.
absolutely.
Okay.
High-grade ore could be shipped to distant smelters.
Yeah.
But lower grade ore required on-site treatment, which further increased the need for capital and expertise.
It sounds like the gold rush drove technological innovation, pushing people to develop new methods and processes to extract ever-dwindling amounts of gold.
Precisely.
Is that right?
And as the gold rush matured, the scale of operations continued to grow, often culminating in massive open pit mines that completely transformed the landscape.
It's a complex legacy to consider,
It is.
how they shaped the land and left behind these scars,
Yeah.
both physical and social.
Right.
But the life cycle of a gold rush didn't always end with the depletion of gold, right?
That's right.
Isn't some areas transition to other activities?
Sometimes it paved the way for other economic activities,
Okay.
as we saw with Leadville, Colorado,
Got it.
which transitioned from gold to silver to base metals.
That's a great example of how these mining towns could adapt and evolve over time. So even though the golden dream might have faded for many,
Right.
the rush itself left behind a lasting legacy,
Yeah.
shaping communities,
Heard that.
industries,
Yeah.
and even the landscape itself.
It speaks to the broader impact of these events.
Right.
How they extended far beyond the gold fields themselves,
Yeah.
influencing economies, politics, and even cultures around the world.
It's an incredible story full of twists and turns, triumphs and tragedies. And I feel like we've only just scratched the surface.
Right.
What should we explore next?
I think we should take a closer look at some specific gold rushes from around the world,
Okay.
focusing on the unique details and fascinating stories that emerge from each region.
Okay, let's dive back into our sources and see what other golden nuggets we can uncover.
Cool. All right, let's embark on our global gold rush tour.
Okay.
Any particular region you'd like to start with?
How about a place that often gets overlooked in the gold rush narrative?
Okay.
Australia and New Zealand.
Oh, yeah.
I feel like we always hear about the American gold rushes, but there's so much more to the story.
Excellent choice.
Yeah.
The gold rushes in Australia and New Zealand had a truly transformative impact, shaping not only their economies,
Right.
but also their very identities.
The Australian gold rushes.
Yeah.
Especially those in New South Wales and Victoria in 1851. Triggered a massive influx of people.
Right.
Leading to huge investments in infrastructure.
Yeah.
It's like the gold rush jump-started the development of these colonies.
Absolutely.
Wow.
Imagine Australia in the 1850s.
Okay.
Still very much in its early stages of colonial development.
Right.
The gold rush brought sudden waves of people, capital, and technology.
Yeah.
Accelerating its growth dramatically.
It wasn't just about cities and infrastructure either. I find it fascinating how the gold rush indirectly led to the development of agriculture in these areas.
Oh, yeah?
People came for gold.
Right.
Didn't find it.
Yeah.
But stayed on because the land was so fertile.
Right.
It's like this unexpected consequence of the gold rush frenzy.
That's a common thread we see in gold rush history.
Yeah.
The initial gold fever might subside.
Okay.
But the people who came, the skills they brought,
Yeah.
the infrastructure that was built,
Right.
these elements often had lasting impacts that extended far beyond the gold itself.
And speaking of lasting impacts,
Yeah.
we can't forget the iconic Golden Triangle in Victoria,
Right.
a region with a rich gold rush legacy that still resonates today.
Indeed.
Yeah.
Now, as we move across the Pacific to North America,
Okay.
we encounter perhaps the most famous gold rush of them all,
All right.
the California Gold Rush of 1848-55.
Yes, the California Gold Rush.
Right.
This one is practically synonymous with the American dream.
Exactly.
The idea that anyone can achieve success with hard work and a bit of luck.
It's an incredibly powerful narrative.
Yeah.
And while the reality of the California Gold Rush was more complex,
Right.
it's undeniable that it had a profound impact on American history and culture.
Okay.
It wasn't just about individual fortunes.
Right.
It also played a crucial role in shaping the political landscape of the United States.
Oh, I hadn't considered that angle.
Uh-huh.
How so?
Well, the rapid influx of people into California
Yeah.
created a pressing need for law and order, for governance in a region that was at the time largely untamed.
Right.
This wasn't just a few prospectors panning for gold in a stream.
Yeah.
It was a massive influx of people from all over the world, all seeking fortune and a new life.
Right.
This sudden population boom, coupled with the economic activity spurred by gold,
Okay.
demanded some kind of structure, some form of organized governance to manage the chaos.
So the gold rush essentially forced the issue of California's statehood?
Precisely.
Wow.
The need for governance, combined with the economic boom fueled by gold,
Right.
ultimately led to California's statehood in 1850.
Okay.
The gold rush was a catalyst for political and social change,
Yeah.
as well as economic transformation.
That's amazing. The gold rush wasn't just an isolated event. It actually accelerated California's integration into the United States.
Yeah.
It's like a domino effect. And to think news of the gold strike sparked a global frenzy,
Right.
leading to similar events in Australia, South Africa, and elsewhere.
Just like this chain reaction of gold feeder
Yeah.
spreading across the globe.
Wow.
Each discovery fueling the next,
Yay.
drawing people in with the promise of wealth and a new life.
Speaking of drawing people in,
Yeah.
let's head north to Alaska and the Klondike Gold Rush.
Okay.
This one has always captured my imagination.
Yeah.
The rugged terrain,
Yeah.
the harsh conditions,
Right.
the tales of adventure and hardship.
Absolutely.
It's the stuff of legends.
And it's been immortalized in literature and film,
Right.
thanks to authors like Jack London and Charlie Chaplin's iconic film, The Gold Rush.
It's incredible how those stories still resonate today,
Yeah.
even for those of us who've never set foot in a gold field.
It speaks to the enduring power of the gold rush narrative.
Right.
The themes of risk, reward,
Yeah.
human resilience, and the allure of the unknown.
Okay.
And the Klondike Gold Rush certainly exemplifies these themes.
Right.
Just think of the journey to the gold fields itself. Prospectors facing treacherous mountain passes and freezing temperatures.
Wow.
It was a feat of human endurance just to get there.
It really makes you appreciate the sheer determination of those who participated in these rushes.
Absolutely.
They were driven by something more than just greed.
Right.
There was a spirit of adventure,
Right.
a willingness to push their limits. That's truly remarkable.
Absolutely.
Yeah.
It's a testament to the human spirit that drive to explore and seek out new opportunities,
Right.
even in the face of daunting odds.
And while we're on the topic of resilience and challenging conditions,
Yeah.
let's not forget the Porcupine Gold Rush in Ontario, Canada.
Right.
This one stands out because it required advanced technology right from the start.
You're right.
Yeah.
The gold in the Porcupine region was embedded in the hard rock of the Canadian Shield,
Okay.
making it inaccessible to the traditional methods of placer mining.
Right.
Forget about panning for gold in streams.
Yeah.
You needed heavy machinery and deep mining operations from the very beginning.
So this wasn't your typical romantic image of lone prospectors panning for gold.
Exactly.
Okay.
The Porcupine Gold Rush was all about large-scale mining companies
Yeah.
with the resources and expertise to extract gold from such challenging deposits.
Got it.
It shows how the nature of gold rushes evolved over time,
Right.
adapting to new geological conditions and technological advancements.
Let's shift gears now and talk about the Witwatersrand Gold Rush in South Africa.
Okay.
This one had a profound impact on the history of the country.
Absolutely.
Right.
The Witwatersrand Gold Rush,
Okay.
which began in 1886,
Uh-huh.
led to the founding of Johannesburg,
Right.
a city that would become a symbol of both South Africa's economic power and its deep social divisions.
This rush was notable not only for the amount of gold discovered,
Right.
but also for the technological innovations that were employed.
Yeah.
Didn't they use a new technique to extract gold from low-grade ore?
Yes. They used the cyanide process,
Okay.
developed by Scottish chemists. It allowed for the extraction of gold from ore that was previously considered unprofitable,
Right.
making the Witwatersrand mines incredibly lucrative.
So it was a revolutionary technology that had a major impact on the profitability of the mines.
Yes.
But I imagine there were social consequences as well.
Unfortunately, yes.
Okay.
The cyanide process, while innovative,
Uh-huh.
also involved the use of toxic chemicals, raising concerns about environmental impact and worker safety.
Right.
And while it led to massive wealth, it also exacerbated racial tensions and contributed to the exploitation of African laborers.
Yeah.
The pursuit of wealth often came at a cost paid by the most vulnerable members of society.
That's a crucial point to remember.
It is.
These events, while celebrated for their economic advancement, often had a darker side.
Right.
It's a complex legacy to grapple with.
Well said.
Yeah.
And it's important to acknowledge that even today, the gold mining industry faces challenges related to environmental sustainability, worker rights, and ethical sourcing.
Those are important issues for sure.
They are.
But for now, let's continue our journey back in time and explore other notable gold rushes from around the globe.
Okay, sounds good.
How about South America?
All right.
I know we have some sources that mention a gold rush in Venezuela that attracted workers from all over.
Ah, yes.
Okay.
The El Canal mine in Venezuela,
Right.
operational from 1871. This mine was, for a time, one of the richest in the world,
Wow.
producing vast quantities of gold that fueled Venezuela's economy and attracted international attention.
Okay.
It drew workers not only from neighboring countries, but also from as far away as the British Isles and the British West Indies.
Imagine that, leaving your home in the UK to seek your fortune in the gold fields of South America.
Right.
It really highlights the global nature of the gold rush phenomenon, how it transcended borders and oceans, drawing people together from across the globe.
It was truly a global phenomenon.
Yeah.
And while El Callao was a major center of activity, it wasn't the only gold rush in South America. That's right.
Our sources also mention the Tierra del Fuego gold rush, which took place in one of the most remote and unforgiving environments imaginable.
Wow.
The southernmost reaches of South America.
That's a region known for its rugged landscapes and harsh weather conditions.
It is.
What kind of challenges did those prospectors face?
Just imagine the sheer determination it took to venture to the remote and unforgiving terrain of Tierra del Fuego, all in pursuit of gold.
Right.
And this rush, unlike the heavily industrialized operation at El Callao,
Right.
was more in line with the classic image of the gold rush.
Right.
Individual prospectors panning for gold in streams, facing the elements head-on.
It's fascinating to see how these gold rushes, even within the same region, could vary so widely in scale. To technology, and social impact. Each one has its own unique story to tell, but they all contribute to the broader tapestry of gold rush history.
Absolutely.
A story that spans centuries, continents, and cultures. It's an epic tale full of adventure, ambition, greed, and the enduring human quest for wealth and opportunity.
And as we've seen, it's a story that continues to unfold even today.
It does.
Remember the modern gold rush we mentioned earlier in Mongolia?
Right.
It seems the gold rush spirit is alive and well.
Yeah.
Adapting to new landscapes and new technologies. It makes you wonder, what will the next gold rush look like?
That's a great question.
Yeah.
Will it be a traditional rush with prospectors staking claims and panning for gold in remote streams?
Right.
Or will it be driven by advanced technologies with corporations extracting gold from the depths of the ocean or even asteroids in space?
It's hard to say for sure.
It is.
But one thing is certain, the pursuit of gold, that enduring human fascination, isn't going away anytime soon.
Right.
But we've focused a lot on the historical gold rushes. Should we discuss the modern gold mining industry a bit?
Definitely.
Okay.
We've explored the history of gold rushes. But the story of gold doesn't end there.
Right.
What about the current state of gold mining?
Okay.
What are the key trends and challenges shaping this industry today?
I'm curious to learn more about that.
Yeah.
Let's dig into it.
Awesome.
Okay, so we've established that gold rushes were these massive transformative events.
Right.
But they weren't all about giant mining corporations, right? What about the individual miners?
You're absolutely right. We can't forget about the millions of small-scale miners who've played and continue to play a significant role in the gold industry.
It's easy to get caught up in the stories of the big strikes and powerful companies. But the reality is that gold mining has always been a diverse activity involving people from all walks of life.
Yeah.
What are some of the challenges these small-scale miners face?
Well, they often face greater challenges and risks than their larger counterparts.
Okay.
They typically lack access to capital, advanced technology, and safety regulations.
Yeah.
This makes their work incredibly difficult and often dangerous.
That makes sense. Our sources highlight that even today, millions of people around the world depend on small-scale mining for their livelihoods.
Right.
Particularly in developing countries, it's a significant part of the global economy, even though it often operates outside the formal regulations and structures of the larger mining industry.
Yeah.
Are there any consequences to this informality?
Unfortunately, yes. That informality can lead to a number of problems, including environmental degradation, human rights abuses, and conflict over resources.
Right.
It's a complex issue with no easy solutions.
It sounds like it's clear that the gold rush spirit, that desire to strike it rich, persists even in the face of these challenges.
Yeah.
What drives these small-scale miners? Is it purely economic necessity, or is there something more to it?
It's likely a combination of factors. For many, it's a matter of survival. They lack other economic opportunities and turn to gold mining as a way to support themselves and their families.
Right.
But I also think there's an element of hope, the possibility of finding that one big nugget that could change their lives forever.
It's that same dream that drove the prospectors of the past.
Right.
The allure of striking it rich.
Exactly. And for some, it might also be a sense of independence, of being their own boss.
Okay.
Of working for themselves rather than for a large company.
It's a complex mix of motivations.
Yeah.
And it highlights the human side of the gold industry.
It does.
These are the stories of individuals who are often overlooked in the grand narratives of economic booms and technological advancements.
It's important to remember that those individual stories are just as important as the larger historical trends.
Right.
They remind us that gold mining, even in its modern industrialized form, is ultimately a human endeavor with all the complexities and contradictions that entails.
Speaking of complexities, we can't talk about the modern gold industry without addressing the ethical considerations that surround it.
Right.
Are there any particular issues that stand out?
We touched on gold smuggling earlier.
Yeah.
But there are other concerns as well, including the environmental impact of mining, the use of toxic chemicals, and the treatment of workers.
Our sources don't delve too deep into those specific areas.
Yeah.
But it's clear that those were significant challenges that the industry needs to address.
Absolutely. As consumers of gold, whether in jewelry, electronics, or investments, we have a responsibility to be aware of these issues and demand greater transparency and accountability from the companies that extract and process this precious metal.
So the gold rush spirit persists, but the context has changed dramatically.
It has.
We're no longer talking about lone prospectors with pans.
Right.
It's a globalized industry with complex supply chains and far-reaching impacts.
Exactly.
Yeah.
As consumers, it's crucial to be aware of the origins of this metal and advocate for responsible sourcing practices.
Okay.
The choices we make can have a ripple effect,
Right.
influencing the practices of the gold industry and its impact on communities and the environment.
So while we've learned so much about the history of gold rushes and the allure of this precious metal, it's important to also acknowledge the responsibilities that come with its extraction and consumption.
It is. The story of gold is not just a tale of adventure and wealth.
Right.
It's also a story about our relationship with the earth and with each other.
As we wrap up this deep dive into the world of gold rushes, what's one key takeaway you want our listeners to walk away with?
I'd say it's this.
Yeah.
The allure of gold is undeniable.
Yeah.
But we must approach this precious metal with a critical eye, considering its history,
Okay.
its present, and its future.
Right.
It's about balancing the desire for wealth and beauty with a commitment to social and environmental responsibility.
That's a great point to end on. Thanks for sharing your expertise with us today. This has been an incredible journey full of fascinating discoveries and insightful conversations.
It was my pleasure.
Yeah.
It's been a fascinating exploration of the enduring human fascination with gold
Yeah.
and the profound ways it has shaped our world.
And to our listeners, we hope this deep dive has inspired you to learn more about the gold industry and consider the choices you make as a consumer.
Absolutely.
Remember, the story of gold is far from over. It's a story that continues to unfold.
Right.
And we all have a role to play in shaping its future.
Until next time.
All right, let's do this. We're going on a journey today, folks, a journey through the Milky Way. Not just that faint band you see across the night sky, but the entire galaxy, our cosmic home.
Exactly.
You guys sent us some incredible excerpts from the Wikipedia article on the Milky Way, and we're going to dive deep, uncover some mind-blowing facts, some surprising details, and by the end, well, you'll have a whole new view of our galactic neighborhood.
That's right. It's easy to get lost when you're talking about galaxies, just the sheer scale of it all. But there's so many fascinating details, kind of hidden in the structure and the history of the Milky Way. We'll be connecting ancient observations to the latest discoveries, explore some controversies, and hopefully by the end, you'll be pondering some pretty big questions about our place in all of this.
I love that. Okay, so I think we've all seen that hazy band of light, across a really dark sky, but what are we actually looking at? Is it just a bunch of stars all mushed together, or is there more to it?
So it really is the combined light of billions and billions of stars, all blended together from the disk of our galaxy. And remember, we're inside the Milky Way. So when we look up at that band, we're actually seeing the edge of our galaxy from the inside out.
So it's kind of like when you're standing in a forest and you're trying to see the entire forest, but you can only see the trees around you.
Exactly. And imagine, this is what's so cool to me. Imagine, like, long before we had telescopes, right? Ancient cultures would look up at that same band of light and come up with their own explanations. The Greeks saw it as milk, like spilled milk from a goddess.
Huh.
Some cultures saw it as a celestial river. Others thought it was like a path for birds migrating across the sky. It's just amazing how, humans have always tried to make sense of what they see up there.
Yeah, it makes you realize that even something as simple as that hazy band, even our view of that has just changed so much over time thanks to science.
It has. And one of the biggest leaps forward came with Galileo, because he was the first to point a telescope at the Milky Way and actually confirm that it was made up of stars.
Oh, wow.
Countless individual stars.
That must have been revolutionary, to think that we're seeing some kind of celestial fluid and then, boom, it's all these stars.
I know.
Okay, so we know that the Milky Way is a barred spiral galaxy.
It is.
Can you break that down for us? What does that even mean?
Okay, so picture a giant cosmic pinwheel, right? But with a bar across the center.
Right.
That's the basic structure. We've got spiral arms, these graceful curves of stars and gas that are spiraling out from that central bar-shaped region. And surrounding all of this is a halo, a kind of spherical region with older stars and these really dense clusters called globular clusters.
So it's way more complex than just like a flat disk of stars.
Oh, yeah. Yeah.
And the size of it, it's just, well, it's astronomical. The Milky Way is massive.
It is huge.
Yeah.
So the Milky Way is about 87,400 light years across.
Whoa.
So to give you a sense of scale, if you could travel at the speed of light, the fastest speed there is, it would still take you 87,400 years to cross our galaxy.
Oh my gosh.
And that's just the diameter. It's only about 1,000 light years thick at the arms.
So it's like this giant cosmic pancake.
I like that.
That's kind of what it looks like. But even with these massive distances, our understanding of that, of its size and structure, has evolved, right? We didn't always know it was this big.
Oh, absolutely not. So back in the 1700s, there was this astronomer named William Herschel, and he actually tried to map the Milky Way. He was meticulously counting stars in different directions.
Wow.
And based on his observations, he actually thought we were at the center of it all.
Oh, really?
Yeah. But later on in the 20th century, astronomers like Edwin Hubble, they made this groundbreaking discovery.
Right.
The Milky Way was just one of many galaxies in a vast, expanding universe.
Oh, wow. So it's like realizing that your hometown is not the only town in the world.
Right.
And our view of the Milky Way keeps evolving, right? Even today. What about, these modern space telescopes like Gaia?
Gaia is a game changer, like completely changing the game. It's up there right now, mapping the positions, motions, and compositions of billions of stars in the Milky Way with crazy precision. We're getting this 3D map of our galaxy, basically, and it's revealing details that we never could have imagined before.
It feels like every new technology that we come up with just unlocks another layer of understanding about our place in the universe.
Absolutely.
And speaking of our place, we're not at the center of all of this, are we? Our sun is, about 27,000 light years away from the galactic center, tucked away in one of those spiral arms, the Orion arm.
Yeah, the Orion arm.
So we're not exactly in the suburbs, but we're not in the, bustling downtown core either.
Yeah, that's a good way to put it.
Yeah.
And it's interesting because our location is actually pretty important when it comes to the possibility of life.
How so?
Well, the galactic center is a pretty crazy place.
Yeah.
There's intense radiation and these powerful gravitational forces from that supermassive black hole that's lurking at the center.
Right.
So being further out in a spiral arm, like we are, puts us in what's called the galactic habitable zone. It's this region where conditions are thought to be, more stable, more favorable for life to even arise and evolve.
So it sounds like we're in kind of a cosmic sweet spot, not too close to the action, but not too far out in the galactic boonies either.
Exactly. And while we're talking about life, it's worth mentioning that our galaxy is absolutely teeming with dot stuff. So many things.
Yeah.
It's estimated that the Milky Way contains between 100 and 400 billion stars.
That's more stars than I can even imagine. But there's got to be more than just stars in the Milky Way, right?
Oh, absolutely. There's dust, gas, black holes, neutron stars, and of course, planets. Astronomers estimate that there's at least one planet for every star in the Milky Way.
Wait, so there could be hundreds of billions of planets in our galaxy alone.
That's what we think.
Yeah.
And that realization, it's really fueled the search for exoplanets, those planets orbiting other stars. Makes you wonder how many other worlds are out there and how many of them might have life.
That thought is both exciting and a little bit terrifying. Hundreds of billions of planets. It's almost too much to comprehend. But wait, there's something else we need to talk about, right? Something about a dark secret lurking within the Milky Way.
You're talking about dark matter.
Yeah.
It's one of the biggest mysteries in astrophysics. We know it's there because we can see its gravitational effects on the visible matter in the Milky Way. But we can't actually see it directly because it doesn't interact with light or any other electromagnetic radiation.
So it's like this invisible force that's shaping our galaxy.
Exactly. It's estimated that dark matter makes up about 80% of the Milky Way's mass. So even though we can't see it, it's the dominant form of matter in our galaxy.
That's pretty mind-blowing. Most of our galaxy is made of something we can't even see or understand. It's like we're working on this giant cosmic puzzle and we're missing most of the pieces.
It really is.
Yeah.
And that's what makes it so fascinating to study. I mean, we're constantly learning new things about the Milky Way, and with each new discovery, we get a little closer to understanding the true nature of our galactic home.
Well, this has been an incredible start to our deep dive into the Milky Way. We've covered so much already, from ancient interpretations of that hazy band to the mind-boggling concept of dark matter. But we've only just scratched the surface.
Well, we have a lot more to explore.
All right, excited.
We haven't even gotten into all the amazing stuff crammed into our galaxy.
Okay.
Stars, gas, dust, black holes, all of it. And trust me, some of those details are even stranger and more fascinating than you can imagine.
I'm intrigued. Looks like we've got a lot more ground to cover in this deep dive.
It's like, when you look up at the Milky Way on a clear night, it's easy to think of it as just this collection of stars. But the space between those stars is far from empty. It's filled with what we call the interstellar medium, and it's this mix of gas and dust. And it actually plays a really vital role in the life and death of stars.
So it's like a cosmic fog just kind of swirling between all those distant suns.
That's a good way to visualize it. And it's not just inert material either. It's where stars are born. So the gas in the interstellar medium, it's mostly hydrogen and helium. It can clump together under its own gravity. And as those clumps get denser, they heat up. And if they reach a critical mass, they ignite. Poof, a new star is born.
So all those twinkling stars we see up there, they all started out as clouds of gas and dust.
Yeah.
That's incredible. I never thought about it like that. What about the dust? The dust just seems like, well, dust.
I know. The dust might seem insignificant, but it's super important for star formation.
Really?
Yeah. Think of it as like a cosmic blanket. It absorbs some of the radiation from young stars, and it helps cool down the surrounding gas. And cooler gas is more likely to collapse under its own gravity and form even more stars.
So it's like this cosmic cycle, a recycling program. Stars are born from the interstellar medium, and then when they die, they expel their own gas and dust back out, and that provides the raw material for the next generation of stars.
You got it. And within this interstellar medium, we also find some of the most extreme, just like fascinating objects in the universe.
Yeah.
Neutron stars and black holes.
Yeah. Neutron stars, those are the ones that are so unbelievably dense, right? Didn't you say like a teaspoonful of neutron star material would weigh billions of tons?
Billions of tons.
Yeah.
Imagine taking all the mass of our sun and squeezing it down into an object, like just a few miles across. That's how dense a neutron star is.
It's crazy. How does something like that even happen?
So neutron stars are born from the death throes of massive stars. So when these stars run out of fuel, they can no longer support themselves against their own gravity, and the core collapses in this just like catastrophic explosion called a supernova. And the protons and electrons in the core, they're forced together, they form neutrons, and the result is a neutron star, this incredible dense ball of neutrons spinning really rapidly and emitting powerful beams of radiation.
So they're remnants of giant stars, like cosmic graveyards, I guess. And what about black holes? Black holes are even stranger, right?
Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape.
Yeah.
And some are formed from the collapse of even more massive stars than those that create neutron stars.
Okay. So if light can't escape, how do we even know they're there?
Good question. We can't see black holes directly, obviously, but we can detect them through their effects on their surroundings. So, for example, if a black hole is, close to another star, it could pull gas away from that star, and it forms a swirling disk of this superheated material, and that material emits X-rays, which we can detect with telescopes. It's like seeing the shadow of a black hole against the bright backdrop of the star it's consuming.
That's a very powerful image. And speaking of powerful, there's a supermassive black hole at the center of the Milky Way, right?
There is. Sagittarius A. It's got a mass about 4 million times that of our sun.
Oh.
And it's the anchor point around which our entire galaxy rotates.
I'm having trouble grasping that. A black hole millions of times more massive than our sun, and it's just sitting there in the heart of our galaxy. It makes our sun seem, I don't know, kind of insignificant, doesn't it?
Well, in a way, yeah. But it's important to remember that every star, including our sun, it plays a role in the grand symphony of the Milky Way. And speaking of that symphony, you mentioned dark matter earlier.
Oh.
Can you tell me a bit more about how it affects the Milky Way's rotation? I'm still kind of fuzzy on that.
Yeah, it's so if we only consider the visible matter in the Milky Way, the stars, the gas, the dust, we would expect stars further out from the center to move more slowly than those closer in.
Okay.
Right. Think about those carnival rides that spin you around.
Yeah.
The further you are from the center, the slower you're going, right?
Right. Makes sense. Because the force of gravity weakens with distance. So you would expect those outer stars to be moving more more leisurely.
But that's not what we see. When astronomers measure the speeds of stars in the outer regions of the Milky Way, they find that they're moving much faster than expected. It's like those outer riders on the carnival ride are somehow zipping around just as fast as the ones closer in. And that discrepancy is one of the key pieces of evidence for dark matter. It's like the invisible hand providing the extra gravity needed to keep those outer stars whizzing around the galactic center.
So dark matter is like the cosmic glue holding the whole galaxy together.
That's a great way to put it. Without dark matter, the Milky Way would probably, I don't know, fly apart. It's not just a passive bystander. It's an active participant shaping the structure and motion of our galaxy.
I like that. So we've been talking a lot about the Milky Way's contents, the stars, gas, dust, black holes, but we haven't really touched on its structure in much detail.
Right.
You mentioned earlier it's a barred spiral galaxy, right? Can you break that down for us a little more?
Sure. Imagine the Milky Way is like a giant cosmic city.
Oh, okay.
And we live in one of the suburbs, out on a spiral arm, far from that bustling downtown core.
I like this analogy. Keep going.
So those spiral arms, like the Perseus arm and the Sagome Centaurus arm, those are where most of the new stars are forming. It's like the suburbs are expanding outward, while the galactic center is more like a mature, established downtown area. And then surrounding the disk is the halo. It's this vast spherical region that contains older stars, and those globular clusters, those are like ancient villages or like relics of the Milky Way's early history.
I love it. So we've got the bustling downtown core, the expanding suburbs, the ancient villages. But there's more to this cosmic city than just that, right?
Yeah, there's also the central bar, this long, elongated structure, like cutting right through the center of the galaxy.
Yeah.
It's like a main street running right through the downtown core, channeling stars and gas inward.
And this bar structure is common in spiral galaxies.
It's actually pretty common. Astronomers estimate that about 2/3 of spiral galaxies have a bar.
Really?
And these bars are thought to play a really important role in galaxy evolution, channeling gas toward the center, which can trigger bursts of star formation and fuel the growth of that supermassive black hole.
So the Milky Way's bar is like this cosmic conveyor belt.
Yeah.
Transporting fuel for the galaxy's engine.
That's a good way to put it. And then there's one more interesting feature of the Milky Way's structure. It's warped.
Warped?
Yeah, warped. So the Milky Way's disk, instead of being perfectly flat, is slightly bent and twisted at the edges. Like, imagine taking a Frisbee and bending it slightly upwards on one side and downwards on the other.
Okay.
That's kind of what the Milky Way's disk looks like.
What would cause something like that?
Astronomers think this warp might be caused by the gravitational influence of the Magellanic Clouds. Those two dwarf galaxies that orbit the Milky Way. It's like those smaller galaxies are tugging on the edges of the Milky Way's disk and causing it to warp slightly.
It's amazing to think that those smaller galaxies can have such an impact on the Milky Way.
Yeah.
Like they're leaving their mark on the very fabric of our galaxy.
Exactly. And it highlights the fact that the Milky Way is not isolated. It's constantly interacting with its surroundings.
Mm-hmm.
Its structure, its evolution, it's all shaped by this like gravitational dance between it and its neighbors.
So we've covered so much ground already, but I'm curious about one more thing. How does the Milky Way move?
Yeah.
Is it just sitting still out there in space, or is it on some kind of galactic road trip?
The Milky Way is definitely on the move. It's rotating. It's moving through space relative to other galaxies, and it's even on a collision course with our nearest large neighbor, the Andromeda Galaxy.
Oh, right, a collision. That sounds pretty dramatic. We talked about that already, haven't we?
We have, but it's worth emphasizing just how significant an event this is. It's going to completely reshape both the Milky Way and Andromeda.
Yeah.
And it's something that astronomers are really eagerly studying to understand all the implications.
So when is this supposed to happen? And what will it look like? Remind me.
Don't worry, it's not happening anytime soon. We're talking like 4 to 5 billion years from now.
Okay.
And when it does happen, it won't be this head-on smash, more like a slow gravitational dance.
A slow dance between galaxies.
Exactly. The Milky Way and Andromeda will just kind of slowly approach each other. Their gravity will pull on each other and distort their shapes. Their spiral arms will be disrupted, stars will be flung out, and vast clouds of gas will collide and trigger these bursts of star formation.
So it's going to be chaotic, but also like creative.
Yeah.
New stars will be born from the wreckage of this collision.
That's right. And eventually, over billions of years, those two galaxies will merge together. They'll form a single giant elliptical galaxy. The Milky Way, as we know it, with its beautiful spiral structure, it will cease to exist.
Whoa.
It's a little bit sad to think about, but it's also incredibly awe-inspiring.
It is.
And this whole process is just driven by gravity, this fundamental force that shapes the universe on like the largest scales.
Exactly. And it's not just gravity. It's this interplay between gravity, the contents of the Milky Way, and its interactions with its environment that have shaped our galaxy into what it is today and will continue to shape it for, billions of years to come.
I feel like we've journeyed through every corner of the Milky Way, its contents, its structure, its movements, even its ultimate fate.
Yeah.
But you hinted that there's still more to the story, something about its formation and evolution.
Oh, yeah.
Okay, so we've talked about the Milky Way's structure, its contents, and even its future collision with Andromeda.
Right, right.
But now I'm curious about its past, its history. How did this massive swirling galaxy, this galaxy we call home, how did it even come to be?
Well, to understand the Milky Way's origins, we need to go way back, billions of years, back to the early universe, like just a few 100 million years after the Big Bang.
That's almost impossible to imagine. The universe back then, it must have been so different.
It was. Back then, the universe was a lot hotter, denser, and smoother. There weren't any stars or galaxies. It was just this sea of hot gas and dark matter spread out, more or less evenly.
So how do we go from that, from this smooth, uniform early universe to the magnificent spiral galaxy that we see today?
Yeah.
How did the Milky Way even begin to take shape?
Well, gravity played the starring role in all of this.
Of course.
Over time, tiny fluctuations in the density of that early universe, almost like little wrinkles in the fabric of space, they started to grow under the pull of gravity.
So these denser regions they attracted more and more matter, like cosmic vacuum cleaners, just sucking in everything around them?
That's a good analogy. These denser regions pulled in more and more gas and dark matter, forming these clumps, and those clumps became the seeds of the first galaxies.
So the Milky Way started out as one of these clumps, just a baby galaxy, gradually pulling in more and more matter over time.
Exactly. And as these proto-galaxies grew, they started to spin. And this spinning motion, it's a key part of how galaxies form their characteristic shapes.
Why is that? Does the spinning have something to do with those spiral arms?
It's all about angular momentum. As matter collapses inward, under the pull of gravity, it starts to spin faster, just like a figure skater pulling their arms in.
Right.
And that spinning motion, it causes the gas and dust to flatten out into a disk. And the denser regions at the center, they form the bulge and the central bar.
So the spiral arms are like the outer edges of the spinning disk, and as the gas cools, it becomes more concentrated, and it forms new stars.
Exactly. And it's a process that's still going on today.
Wow.
Even now, the Milky Way is still forming new stars in those spiral arms. It's a very dynamic, evolving system.
You mentioned earlier that the Milky Way likely went through this major merger, like with another galaxy about 11 billion years ago. How can astronomers even tell that something like that happened so long ago? It's like galactic archaeology.
It is. And like archaeologists, astronomers have to piece together clues to understand the past. So one clue comes from studying the motions of stars in the Milky Way's halo, that spherical region surrounding the disk.
Okay. What can the motions of stars tell us about a past merger?
So if a galaxy experiences a major merger, it disrupts the motions of stars, especially those in the halo.
Okay.
So you might see streams of stars moving in unusual directions, or clusters of stars with like very different velocities from their neighbors.
Huh.
It's like seeing the lingering effects of a cosmic collision billions of years after it happened.
So those unusual stellar motions, they're like scars, reminding us of the Milky Way's like tumultuous past.
Exactly. And there's another clue that comes from the chemical composition of stars. Different galaxies have different chemical fingerprints based on, the amounts of heavier elements they contain.
So by studying the chemical makeup of stars, astronomers can tell if a star formed in the Milky Way or if it was, I don't know, adopted from another galaxy.
That's the idea. And when we look at the chemical compositions of stars in the Milky Way's halo, we see evidence of stars that seem to have come from a different galaxy. It's like finding traces of a different culture in an archaeological dig.
So by combining these clues, the stellar motions and the chemical composition, astronomers can like build a picture of the Milky Way's merger history.
Exactly. And the evidence suggests that our galaxy has experienced a series of mergers throughout its history. These mergers have brought in new stars, new gas, new dark matter, and they've really helped to shape the Milky Way into the galaxy we see today.
It's amazing to think that our galaxy isn't this static object, just frozen in time. It's this dynamic, evolving system with this rich and complex history of collisions, mergers, and growth.
And this process isn't over. We already know the Milky Way is destined for that major merger with Andromeda, but it's also possible that the Milky Way is still merging with, smaller dwarf galaxies like those Magellanic Clouds we talked about earlier. It's constantly growing and changing.
It's almost like the Milky Way has an appetite, constantly nibbling on its smaller neighbors.
That's a great way to put it. But eventually, the supply of fresh gas and smaller galaxies will dwindle. And that brings us to the question of the Milky Way's ultimate fate.
Yeah, what happens to a galaxy when it runs out of fuel for new stars? Does it just, I don't know, fade away?
In a way, yes.
Mm-hmm.
After the Andromeda merger, the newly formed elliptical galaxy, it'll probably continue to accrete some gas in dwarf galaxies for a while. But eventually that process will slow down. And without new gas to fuel star formation, the galaxy will gradually fade as its existing stars age and die.
So even after that dramatic merger with Andromeda, the Milky Way story, it doesn't end there. It just enters this new phase, this slow decline, and its starlight gradually dims.
That's what we think. The once vibrant spiral galaxy with its bursts of star formation, it will become this quieter, more subdued elliptical galaxy dominated by cooler, redder stars. It's like a cosmic bonfire slowly burning out as this fuel is consumed.
It is a little bit melancholy to think about, but also just fascinating. It makes you appreciate the cycles of creation and destruction that really drive the evolution of the universe.
I agree. The Milky Way story is a reminder that even the grandest structures in the universe are constantly changing, evolving, and ultimately fading away. But their stories don't end there. The material they're made of, it's recycled, perhaps to form new stars and galaxies in the distant future.
This deep dive into the Milky Way has been truly awe-inspiring. We've journeyed from its humble beginnings as just this clump of gas and dark matter to its upcoming merger with Andromeda and its eventual fate as a fading elliptical galaxy.
Yeah.
It's a story that spans billions of years and touches on some of the most fundamental questions about the universe.
It has been a pleasure sharing this cosmic journey with you. And who knows what amazing discoveries await us as we continue to explore our galactic home and the vast universe beyond.
I can't wait to find out. Thanks for joining us on this incredible deep dive into the Milky Way. Until next time, keep looking up at the night sky and pondering the wonders of the cosmos.
Well said. And remember, with every new discovery, we gain a deeper appreciation for our place in this vast and ever-changing universe. Welcome to another Deep Dive. Today we're tackling the world of algebra. We've got all those notes and articles from Wikipedia's algebra page ready to go. And, well, we're not going to make this a lecture. Just pure algebra insights, ready for some aha moments.
Yeah, definitely. Algebra is a really beautiful subject,
Yeah.
and it's way more relevant to daily life than most people think.
Okay, I mean, we've all seen algebra in school,
Yeah.
like solving for x and all that. But what exactly is algebra? Is it just like arithmetic with fancy symbols?
That's a great question to start with. You're right. We often think of variables like x and y, but algebra is much deeper. It's like taking arithmetic and generalizing it.
So you're saying instead of just numbers, we're looking for patterns and relationships.
Exactly. Like think about 2 + 5 = 7. That's just one case. But in algebra, it's more like A + B + A, where A and B could be anything. It's the commutative property, and it always works, whether we're adding, I don't know, apples or galaxies.
That's so interesting. So the x and y are just placeholders for any value.
Yeah, precisely. They let us express relationships and find unknown quantities. That brings us to expressions and equations. An expression is like by 2 + 3y 5. An equation is when two expressions are equal, like x + 4 = 9.
So solving for x is like finding that missing puzzle piece.
You got it. And that's where we get the balancing act of algebra. Whatever you do to one side, you have to do to the other side too.
Okay, that makes sense. Now what about polynomials? I remember those from school. but it's all a bit fuzzy.
Polynomials are expressions with multiple terms. Each term has a constant and variables with non-negative powers, like by 2 plus 3 by 1.
So each term is like a building block.
Right. And polynomials can get pretty complex. They're used a lot in the real world. Like, imagine modeling a projectile. The height over time can be a polynomial equation.
So something abstract like a polynomial can describe something like the path of a ball.
Absolutely. That's just one example. Polynomials are used everywhere. Physics, engineering, economics, you name it.
So before we jump into other types of algebra, I'm curious about, what was it like before the 19th century? Were they just obsessed with polynomials?
Well, they were fascinated by them. A lot of early algebra focused on finding the roots of polynomial equations, like what values make the equation true. They even had formulas for quadratics, cubics, and quartics.
I kind of remember those formulas. They seemed like magic.
They can feel that way, but mathematicians hit a wall with polynomials of degree 5 or higher. There's no one formula for those.
It's like Stolas distribution, finding a limit in algebra. Did this make them explore new areas?
Absolutely. It was a turning point. It led to a shift from specific solutions to understanding the structure of algebra itself. And that's where linear algebra comes in.
Linear algebra. I've heard that before. Does it involve even more complex equations?
Linear algebra takes things to the next level.
Yeah.
But it's not about complexity for its own sake. It helps us solve realistic problems with systems of equations. Imagine solving multiple equations at the same time.
Whoa, like juggling equations. How do we even do that?
That's where matrices come in. They might look intimidating with all those numbers in a grid, but they're really elegant for representing systems of equations.
Okay, so instead of a bunch of equations, we have one matrix. But how do we find the values of x and y?
That's where matrix operations come in. We can add, subtract, multiply, and even invert matrices. It lets us manipulate the system, just like we manipulate equations.
Sounds like matrix magic.
It's a powerful set of tools for solving real problems.
This is fascinating. It's like we can go beyond single equations.
You got it. And as we go deeper, we'll see how these concepts connect even more.
Before we move on, though, I've always wondered, how can systems of equations have no solution? Or even infinite solutions?
Great question. That's where algebra and geometry connect. Remember how each equation is like a line? The solution is where those lines intersect.
Okay, so if they intersect,
yeah,
we have one solution, but what if they don't?
If they're parallel,
yeah,
there's no solution. It's like trying to find where parallel roads meet. That's an inconsistent system.
Makes sense. But what about infinite solutions?
If the equations represent the same line, then every point on that line is a solution. It's called a dependent system.
It's like having two maps to the same destination. I'm really starting to see the power of linear algebra.
You're absolutely right. And as we go deeper into algebra, we'll see how these concepts and tools become even more powerful and interconnected.
This is all incredibly interesting. Ready for the next level. What's next on our adventure?
Next, we're going into abstract algebra. Get ready to go beyond numbers and equations.
Abstract algebra. Sounds fascinating and intimidating. Can't wait.
So, we talked about elementary algebra and linear algebra, both super useful. But now we're going into abstract algebra. It's a whole new way of thinking.
Bring it on. I gotta admit, though, abstract algebra sounds a bit scary. Is it really that abstract?
It can be, but it's also beautiful and insightful. Think of it like this. Elementary and linear algebra are like using tools in a workshop. Abstract algebra is like studying the design of those tools.
Yeah. Instead of solving equations, we're looking at the blueprints of math itself.
Exactly. Abstract algebra is about studying structures like groups, rings, and fields.
Okay. I've heard those terms, but not sure I really GT them. Let's start with groups. What makes a group a group?
A group is a set of elements. They could be numbers, symmetries, even movements, like rotations. What matters is how they're combined using an operation, and that operation has to follow rules.
So it's not just the elements, but how they interact.
Exactly. The operation has to be associative, meaning grouping doesn't matter. There's also an identity element. It's like a neutral element. And every element needs an inverse, something that undoes the operation.
Whoa, lots of new stuff here. Can you give me a real example?
Sure. Imagine a clock face and rotating the hand. We could have rotations of 120 degrees, 240 degrees, and 360 degrees. Combining those rotations forms a group. It's associative. The 360-degree rotation is the identity because it gets you back to the start. And each rotation has an inverse, like 120 degrees and 240 degrees.
Okay. I think I'm getting it. The clock is helpful. It's the structure, the relationships. that make it a group. So what about rings? How are they different?
Rings are a bit more complex. They have TDWO operations, often like addition and multiplication, but they don't have to behave exactly like those. Key rule is addition must form a commutative group, and multiplication must be distributive over addition.
Distributive. I vaguely remember that. Remind me.
Sure. It means if you multiply a sum by a number, it's the same as multiplying each part separately and then adding. So AB plus C is the same as AB plus AC.
Okay. Coming back to me now. So rings have two operations with rules. What about fields? Where do they fit in?
Fields are like rings with even more structure. Every non-zero element has a multiplicative inverse, so you can divide by anything but zero.
So fields are rings where division always works.
Exactly. Think about rational numbers. Fractions with integers, they form a field. You can add, dot subtract, multiply, dot divide, and you always get another rational number.
Right, that makes sense.
Yeah.
So groups, then rings, then fields. Each one gets more structured. This IS getting pretty abstract. What's the point of all this?
Yeah.
Any real-world use?
The beauty is, abstract algebra might seem detached, but it actually underlies a lot of applications. One example is cryptography, secure communication.
Cryptography, algebra, and secret codes. How does that work?
Secure communication needs encryption, so only the recipient can read the message. And a lot of encryption techniques use abstract algebra, especially groups and fields.
Yeah. These rules and structures, they keep our online stuff safe.
Exactly. Abstract algebra is the foundation for cryptography.
My mind is blown. But before we get too deep into applications, can we go back to the core of abstract algebra? We talked about structures, but how do mathematicians actually study them?
Good question. One way is comparing structures, seeing how they're similar or different. For this, they use things like homomorphisms and isomorphisms.
More new words. Explain, please.
A homomorphism is like a map between two structures. It preserves the operations, like a translator between languages, keeping the meaning the same.
So it's a bridge between two algebra worlds.
Exactly. And an isomorphism is a special kind of homomorphism. It's a one-to-one mapping, meaning each element in one structure matches a unique element in the other. It shows that two structures are basically identical, even if they look different.
Like two cities with the same layout, but different buildings.
A perfect analogy. Understanding these mappings helps mathematicians categorize structures. It's like organizing blueprints.
This is changing how I think about math. It's not just equations. It's exploring the architecture of math itself.
Exactly. And there's another concept, subalgebras.
Subalgebras, like a subset within a bigger structure.
You got it. It's like zooming in on a neighborhood. It follows the city's rules, but has its own character.
Can you give me an example?
Think of even numbers under addition. It's a subalgebra of integers under addition because it follows the same rules. The sum of two evens is always even.
Okay, it's like a self-contained community within the bigger city of integers.
Great visualization. Studying subalgebras helps us understand larger systems.
This is really opening my eyes. Algebra is not just abstract. It has real-world uses like cryptography. It's amazing.
Absolutely. And it's constantly evolving. New structures, new connections, new applications.
Mind-bending stuff. I'm seeing algebra in a whole new light. It's a way of thinking, a language for math.
Exactly. And this journey's not over. There's always more to learn.
I'm excited to keep exploring. So before we wrap up, what else is fascinating about algebra? Something for our listener to think about.
One thing that always gets me is how abstract things like groups and rings can have real-world uses.
Like cryptography. It's like a secret code.
Exactly. Think about the algorithms online or the encryption keeping your data safe. Algebra's everywhere.
That's right. I'm going to start looking for algebra everywhere now.
I bet you'll be surprised.
I'm sure will.
Keep exploring, keep asking questions, and keep those aha moments coming.
Wow. I'm really starting to get how big algebra is. It's like we went from basic arithmetic to this amazing abstract stuff.
Yeah.
But before we finish, is there anything else we should look at?
There's always more to find in algebra. It's always changing.
That's what's so cool. Are there areas that are even more abstract, like beyond groups and fields and rings?
There is. Ever heard of universal algebra?
Universal algebra.
Yeah. It takes a really broad view, looking at what's common across all algebraic systems.
So, like zooming out to the highest level, finding the patterns, connecting everything.
Exactly. It's like searching for the universal language of algebra.
Wow. That's mind-blowing. So universal algebra is about the threads that connect the whole tapestry.
You nailed it. It's like seeing the whole forest.
This is making me rethink algebra completely. It's not just equations. It's about the essence of math itself.
That's a great way to put it. That's why algebra is so important. It's the language of math, and it helps us analyze complex systems.
I'm feeling a new appreciation for algebra. It's been a journey, from struggling with equations to understanding this bigger picture.
And the journey isn't over. Keep exploring, and you'll find algebra everywhere.
I will. This deep dive has been incredible. Thanks for being our guide.
It's been my pleasure. And to everyone listening, keep those algebraic insights flowing.